The universe is enormous. And when I say enormous, I'm talking millions, no, billions of galaxies, each with millions, no, billions of stars, and also countless planets circling these celestial bodies to boot. And in all this vastness, the chances of life existing somewhere else on one of these worlds seems, well, almost certain. And yet, despite decades of searching, we haven't found a single sign of extraterrestrial life. No messages, no visitors, nothing. This mystery was first articulated in 1950 by the brilliant physicist Enrico Fermi. During a casual lunch with colleagues at Los Alamos National Laboratory, the topic of UFO sightings and the possibility of extraterrestrial civilizations came up. As they joked and speculated, Fermi suddenly asked, "Where is everybody?" At first, it seemed like a simple remark, but Fermi wasn't joking. He was struck by the contradiction. In a universe with billions of stars and potentially trillions of planets, even a modestly advanced civilization should have spread across the galaxy by now. And with the universe being billions of years old, there's been more than enough time for this to happen. So, why haven't we seen any evidence? Why is the cosmos so silent? This is the Fermi Paradox. The haunting question: if the universe is so big and so old, where is everybody? Let's jump into this mystery. With some optimistic theories to some, frankly, chilling possibilities, let's explore why the cosmos might be quieter than expected, or why we might wish it stayed that way. To understand the Fermi Paradox, we first need to grasp just how vast and ancient the universe really is. In our galaxy, the Milky Way, it's home to around 400 billion stars. And out there, scattered amongst those stars, are an estimated 100 billion planets. Many of these are in what scientists like to call the habitable zone, otherwise known as the Goldilocks zone. This is where conditions are just right for liquid water to exist on a world, and with it, the potential for life. And that's just our galaxy. The observable universe contains at least 2 trillion galaxies, each with billions or trillions of stars. It's almost impossible to comprehend numbers this big. So, there's a simpler way to think about it. For every single grain of sand on Earth, there could be 10,000 planets out there. Now, here's the kicker. The universe is old, about 13.8 billion years old. That's plenty of time for intelligent civilizations to rise, evolve, and spread across the cosmos. Even if a vanishingly small fraction of the planets harbour life, and a small fraction of those become complex or multicellular, and an even smaller fraction become technologically enabled, there should still be thousands, if not millions, of advanced civilizations out there. So, why don't we see or hear any of them? Why is the night sky so silent? To understand how unlikely it is that we are alone, we can turn to something called the Drake equation. In 1961, astrophysicist Frank Drake devised this equation as a way to estimate the number of advanced civilizations in our galaxy capable of communication. It's a deceptively simple formula that breaks the problem into smaller pieces. The number of civilizations with which humans could communicate, the mean rate of star formation, the fraction of stars that have planets, the mean number of planets that could support life per star with planets, the fraction of life-supporting planets that develop life, the fraction of planets with life that develops intelligence, the fraction of intelligent civilizations that develop communication, and the mean length of time that those civilizations can communicate. Of course, this equation isn't meant to give us a precise answer. It's more like a framework for thinking about the problem. But even if we plug in conservative estimates for each term, numbers suggest that there should be thousands, if not millions, of advanced civilizations in the Milky Way alone. And yet, here we are. No signals, no visitors, nothing. It's a contradiction that's hard to ignore. But why? Let's start with the optimistic possibilities, because maybe the silence of the universe isn't as eerie as it seems. One theory, known as the rare Earth hypothesis, suggests that maybe it's just not as easy as all that. Perhaps our planet is special. The rare Earth hypothesis posits that complex, intelligent life is exceedingly rare in the universe simply due to the unique combination of conditions required for its development. Conditions that include a stable climate, a planet with a star's habitable zone, a protective magnetic field, tectonic activity, a large moon for climate stabilisation, and also a quiet galactic neighbourhood. Additionally, there are biochemical and evolutionary events that may be essential for life to progress from simple organisms into intelligent beings. This perspective suggests that Earth may be one of the very few places where life has emerged, emphasising humanity's potential uniqueness in the cosmos. A nice thought. But when you look at the sheer numbers, replication of Earth's conditions elsewhere seems, well, certain. Another idea is that we're just not listening in the right way. Imagine trying to hear a whisper in a noisy room. Unless your ears trained to the mouth of the speaker, you're likely to miss the message entirely. And that's essentially what we might be doing in our search for extraterrestrial intelligence. Our best efforts, like the SETI program, use radio telescopes to scan the skies for signals. But this uses an anthropocentric assumption that radio or light-based signalling is the technology of choice for advanced civilizations. Now, galactic species may have mastered communications technology that exploits things like quantum entanglement or gravitational waves, or even something that we can't even imagine. The universe is vast, and our technology is, well, limited. I mean, look how much our tech has changed in just 100 years. With millions of years to play with, alien tech signatures could be everywhere, and we simply can't perceive them. With the use of radio telescopes, we've only just begun to scratch the surface, which brings us to another possibility. What if we're not alone, but advanced civilizations are deliberately avoiding contact? Perhaps aliens have decided that it's better to let us develop naturally, without interference, keeping us isolated from the hustle and bustle of the intergalactic communication and commerce until we're deemed advanced enough to contribute. This feeds into an idea known as the zoo hypothesis. In this scenario, humans on Earth are treated like animals in a wildlife reserve, safe and protected from outside influences, observed but not disturbed, and also not allowed to run free and ruin civilised parts of the galaxy with nuclear bombs or K-pop. And then there's the simple fact that interstellar communication and travel are really, really hard. Even if there is a civilization out there, they might not have the technology or energy to send messages across vast distances of space. Think about it. Even with our fastest spacecraft, it would take us tens of thousands of years just to reach the nearest star. And although we've been sending out radio signals since the early 20th century, due to something called the inverse square law, those signals get exponentially weaker the further they get from Earth. Only highly directed signals would be easily detectable to us. Advanced civilizations might face similar challenges or limitations to their technology. But while these optimistic explanations are comforting, they're not the only possibilities. What if the universe isn't quiet because it's kind, life is rare, or technology limited, but because it's dangerous? This brings us to one of the most unsettling ideas related to the Fermi Paradox, the Great Filter. Now, the Great Filter is a kind of cosmic barrier, a theoretical stage in the development of life that's incredibly difficult to overcome. So difficult that, after this point, life or civilizations are just snuffed out. If the filter is real, it could explain why we don't see advanced civilizations all over the universe. Nobody ever makes it that far. But the scary part is, we don't know when this filter will occur. Maybe the filter is behind us. The development of nuclear weapons could be the filter, for example, which could have gone wrong, but we've survived it so far. It could be that conditions for life, or that becoming an advanced civilization is so rare that just getting to this point is an astronomical fluke. Now, if that's true, then we're incredibly special, possibly one of the only intelligent species in the entire universe. But what if the filter is ahead of us? What if there's something unforeseen that nearly every advanced civilization encounters? Something so catastrophic that it wipes them out before they can explore the stars? This idea raises haunting questions. Could the challenges we face today, like climate change, resource depletion, bioengineering, or even artificial intelligence, be our great filter? Are we racing towards our own doom without even realising it? The Great Filter is both a warning and a mystery. If we want to survive, we need to figure out if there is one, and if there is, how to avoid it. But unfortunately, this is not the most unsettling possibility. Perhaps the universe is unnervingly quiet, not because of a lack of advanced alien life, but because the universe is dangerous. This brings us to the dark forest hypothesis. Imagine this. The universe is like a dark forest. Every advanced civilization is a hunter, hiding silently, afraid to make a sound, carefully covering any tracks to disguise its very existence. But why? Because the moment they reveal themselves, they risk being discovered by something or someone far more powerful than themselves, something potentially hostile. Now, in this scenario, we don't see any techno signatures out there because advanced civilizations are deliberately staying quiet, erasing any trace of themselves to avoid becoming a target. And in this theory, we're the foolish ones, shouting into the void with our radio signals, hoping that someone will answer. Calling out to the stars willy-nilly might be the last thing we ever do. Instead of a friendly, we come in peace, we might be met with resistance is futile. Not ideal. I'm sure you'll agree. And then, of course, there's the simulation hypothesis. What if we're not hearing from anyone else because we're in a simulation? In this theory, the universe we experience is an artificial construct, designed by an advanced civilization for reasons that we can only guess. Aliens might not exist in our reality because they're just not part of the program, or at least not yet anyway. And then, of course, there's the possibility that we've already missed our chance. What if advanced civilizations existed millions or billions of years ago but have since vanished? The evidence would be long gone, erased by time, cosmic catastrophes, or even their own self-destruction. This leaves us with a sobering thought. Maybe the universe isn't empty at all. Maybe it's just littered with the ruins of all the civilizations that came before us. All of these ominous theories lead us to a bigger question. If the universe is so quiet, what does that mean for us? The Fermi Paradox isn't just about finding aliens, it's about understanding our place in the cosmos. If we're alone, it means we're incredibly rare, perhaps the only intelligent species in the universe capable of shaping the future. And that makes every decision we make, every technological advancement, every global challenge immeasurably important. But if we're not alone, it raises just as many questions. How should we prepare for contact? If we do manage to find them, what could we learn from civilizations that have succeeded or failed? No matter how you look at it, the silence of the cosmos is a call to action. It challenges us to explore, to innovate, and to ensure that we don't become just another quiet planet in the void. So, what do you think? Which theory explains the Fermi Paradox? Are we alone? Or is the truth stranger than we can imagine? Let me know in the comments. And if you enjoyed this journey through the cosmos, don't forget to like, subscribe, and check out some of my other videos. I'm still a small channel and all those things really help me out. Thanks for watching.